Okay.
Cool. Okay. All right. Let's get started. Well, hello everybody. To all those who've made it so far, thank you for attending today's strategy show and tell. In today's session, you'll be hearing about the progress thus far on the network redesign project. So before we begin, I'd just like to take a moment to point out that the primary HackIT values and mission that this project aligns to are the internet era ways of working, and also simple, secure, reusable technology. A quick point to note is that as we progress through the presentation, you'll notice that some of the values and missions have been tagged where appropriate for the actual work stream itself. So with that being said, I'd just like to pass you over to Chidi, who will share with us more details.
Thanks, Camille. Couldn't have asked for a better introduction. Right, so the last time we were out here, we told you that the network redesign project was part of Project Web First. Now we're going to define Project Web First very loosely as a collection of activities or projects with the sole purpose of giving the internet a more central role in HackIT computing. Now, why are we redesigning our network? Doesn't it work? Well, yeah, it does. But in some places, not quite as we would like. The reasons we're redesigning the network from the ground up fall into two main categories, the financial and the technical. In terms of the financial, if you take a look at things, we are overpaying for what amounts to very little, right? And I will give examples of that as we go along. But worse than that is that at least until very recently, we were paying for services that we had stopped using. So we thought, okay, we would use this opportunity to take a look of, everything that's going on on our network and see where we can dispense with these needless expenses. The technical issues are more straightforward. The use of open standards has made it such that upgrading our network is like pulling teeth. Some of the newer stuff, because a network that's been around as long as ours, some 25 years, as you upgrade it, you don't upgrade it all in one fell swoop. That's unique to just this effort. You upgrade it in bits and pieces. And what happens is that as we try to upgrade one part, if we find that it can't quite play well with another part, and so we have to install things to make the new play with the old. And this has the net effect of making our network more complicated than it needs to be in terms of management and maintenance. So by the time we're done with this, our network will have three characteristics. One is that it will be a very simple network in terms of its design so that it's easier to manage and maintain. The second thing is that it will use open standards so that future upgrades will not be as painful as what we've had to endure all this time. And last but not least, it will be a predominantly wireless network. You might even have heard the phrase bandied that by the time we're done, HackIT will be just one giant hotspot. So what do we have? Well, we begin by saying that the HackIT network breaks out into three layers. And this is not uncommon. For networks of this size, this is fairly common. The three layers are the access layer, the distribution layer, and the core layer. We're going to go over that now, over those three layers now. The access layer is the layer that's closest to the users. And I guess that's why the name access is rather apt. It gives you access to the rest of the network. It's the network to which every end user device, whether you're talking about a Chromebook, a Chromebox, or a wireless AP, a printer, any end user device will connect to an access switch. Now you can't see the access switches there in the comms room, but they look something like this. Now I'd like to draw your attention to the fact that there are actually two classes of switches here. You can see that the ones below have got more ports than the ones above. The ones below are the 48-port switches. The ones above are called the 24-port switches. I want you to keep that in mind, because when we talk about port utilization, this is what we'll be talking about, okay? Right. So there are 219 access switches spread out across HackIT. And what they do is simply gather information from the disparate end user devices, whether it's your laptop, your Chromebook, whatever. It gathers all that information, gets it ready to be transmitted to the next layer, which is called the distribution layer. And it might help you if you remember the distribution layer is also called the aggregation layer. And the devices we've got at the aggregation layer look something like this. Right, so what these devices do is, and we have 16 of them in Hackney, is that they collect all the information that have been given to us from over 100 sites, some 219 access switches and routers and everything else, gathers them together and prepares them to be transmitted to the core layer. We have 2 core switches, one in Stoke Newington, one in the Hackney Town Hall basement. And I guess these two, the presence of these devices makes these 2 places the 2 capitals of the Hackney network, if you want to think about it in that way. So they look like this. I know this looks like something from the 40s, but it was only made in 2005, and it only went end of life last year. This is one of Cisco's finest creations, and it's tasked with gathering all the data that has come all the way from the access layer through the distribution layer right through to the core layer. And from the core layer, it's only tasked with sending all of this information out to the internet. Now, this device is so good that we even have some of these working in our distribution layer. Now, what I've described so far are the equipment you would find in corporate settings, the corporate offices, and so on and so forth. But not all of us work in such settings. You have people that work in what I like to refer to as the Hackney and the community type settings. So children's playgrounds, the morgue, old folks' homes, places like that, where you usually have a very small staff presence. And for such places, we have this. This is not too different from what you would find on your home broadband network. Matter of fact, if I showed you the back of it, there, just 4 ports. So you're looking at connecting 1 or 2 users and a printer. And this is all you'd need to do just that. Now, how does all this tech hang together? To consider that, we'll have to look at the kinds of networks, the kinds of connections that Hackney has got in place. There are 3 main connections we've got in place. The first of them is the dark fiber connection. These are the fastest connections, and as a rule of thumb, you would mostly find them around Hackney's biggest buildings. So you'd be looking at finding the dark fiber connections around the HSC, Town Hall. You'd also find it around buildings that surround these big buildings. So Morris Bishop, Robert House, the Annex, such buildings are on the dark fiber network. Following that, you've got the LAN extensions. Now, do you remember when I said that we are paying for things we're not using, or we're paying a lot and getting very little? This is what I was talking about, the LAN extensions. We have connections that are only 10 meg. The LAN extension from Broadway Market is a 10 meg connection. We're paying over $3,000 for that every year. That's about £280 a month for 10 meg. It's the kind of thing that makes you want to run for president, but this is what we have. The remote access connections, these are the ones that will connect all those Hackney and the community type places back to the main campus network, the dark fiber network. So once again, the 3 connections are the dark fiber, the LAN extension, and the remote access VPNs. How do these relate to the switches that I've just described? It's a good question. The core switches, well, they reside in the 2 capitals. Obviously, those 2 buildings are on the dark fiber network, so they will connect by dark fiber. The distribution to core, all distribution switches will connect back to the core switches through the dark fiber network. So the only variation happens in the access to distribution connection. So if you've got an access switch in Broadway Market or de Beauvoir or places like that, which are not on the dark fiber network, they would connect using a LAN extension. And of course, the devices that are in those Hackney and the community type places will connect back via the remote access VPN. So that's how all that marries up. So that's pretty much it about the old stuff, what we've got right now. So the question is, what are we looking to get to? You know, when I said at the beginning that our network, when we're done designing it, would have 3 main characteristics. It would be what? It would be simple in its design, and therefore it'd be easier to manage and maintain. It would use open standards so that what? So that we could upgrade it more easily than we've been upgrading what we've got so far. And last but not least, it would be a predominantly wireless network. Now that wireless network part that's where we come a bit of a cropper. Because in order to have a predominantly wireless network, you've got to decide what's going to happen with these guys. There are some 3,246 of them scattered all around Hackney's compute space. About 1,563 of them are in the HSC alone. They don't do wireless. And yet, virtually every desktop device will connect first to this, and then it's this that connects to the port. So in other words, it's this guy that determines port utilization. It's this guy that determines whether you would have a 24-port switch or a 48-port switch. So you can see how this is all marrying up. So the question becomes, what do we do about them? We can't just look around and go, okay, do you know what? Let's just swap out our old switches for our new switches. We can't. Why? Because there is a project in place that is looking at replacing the hardware phones with the software variants. So what would happen is that if we bought a 48-port switch and stuck it in a place, a couple of months down the line, when all the phones have been removed and Chrome devices are now connecting wirelessly, you might now find that your 48-port switch now has only 3 ports being used, maybe 2 for the wireless access points, 1 for the printer. In that kind of situation, we would have done what Henry very famously referred to as pissing money up the wall. Language, Henry. But the thing about it is, it's a lot of waste. So how do we prevent that waste? Well, we did some analysis, and we discovered that this is what our utilization looks like at the moment. The 48-port switches comprise about 125 of the 219 access devices. The 24-port switches closely follow them. And then, of course, the ones in blue, these guys over here, those are the routers. These other devices probably don't have anything connected to them, but the method that we used to gather the data showed that they were there, so we counted them anyway. So once again, how do we get past these guys? Do we wait for the phone substitution exercise to be completed and then take another measurement then? We could, but that would make our project dependent on that project. And so we decided we probably didn't want to go down that road. Good thing we didn't, because Yvonne's teams have been able to find 2 solutions, and neither of those dogs hunted. So we went away and came up with a model that would generate the least amount of disruption for the business model that we're operating now, but would also give us the least amount of waste after all the phones have been eliminated. Okay? And having done that, this is what we came up with. So the 48-port switches are still quite the most populous number of switches, but they're not the most dominant switches. A combination of the 24-port and the 8-port switches would account for more than half of the network. This would generate savings of about 130 grand, as against simply swapping out what we've got now. So we might not be in business to turn a profit, but we have to be cost effective. This was what the model that we sent to Rob. This was the model on which we based the business case that we sent to Rob for approval. But then the coronavirus struck and presented new opportunities. Those phones that we were thinking could not be moved, we have to be considerate, we have to think what if. Well, now even the call centers are using those services which we had marked out as undesirable or as not quite good enough. They're now being used by even our call centers. So that makes it possible for us to now consider removing 100% of the phones where necessary. We do this, we save 200 grand over simply swapping out what we've got for the new stuff. So now we know what we need to, how many switches we need. We've worked out how many switches of how many kinds of how many switches we need. The question now is, who's going to give us that tech? We looked around and we settled on 2 suppliers, and I'm going to call them the little brothers. Why? Well, you'll see in a minute. In the one corner, we've got Meraki. They're a subsidiary of Cisco. You're familiar with them already, even if you don't know it. They're the guys that supplied us our wireless AP, the wireless APs that provide our wireless capabilities. In the other corner, you have Aruba. They're a subsidiary of HP. They built virtually every computer and printer we used before we migrated to Chrome devices and Xerox printers. So it was now a matter of getting devices from these guys, Isaiah setting up a test lab in the basement of the town hall, which doubled as his secret lair. And we conducted tests over 6 weeks. And the tests mainly were around things like, does it support our current, does it support Wi-Fi? Well, the Meraki one certainly should. It's the same manufacturer. What about the Aruba one? Does it? It did. VoIP. Will it allow us to continue making phone calls? Even if, yeah, we're talking about removing all the phones, but what if there are a few of them still left? Will we still be able to continue using those? Can we manage it from the cloud? How easy is it to use? How secure is it? What does it cost? And a host of other tests. Some of these tests involved us taking a switch to a certain site after dark, swapping out what they've got there and putting our own switch in, and testing to make sure that everything was tested to make sure that when we came to a decision, it would be definitive. And in the end, we decided to go with the solution from Meraki. So it's a shiny set of kit, but let's take a look at them again, yeah? Shiny kit. But the question is, how does it differ from what we've got now? What makes it different from what we've got now? Well, the old kit only speaks this language. And if you work on the infrastructure team and you're not Isaiah and you're not Ido, well, you're closer to that. And this is for those of them on the infrastructure team that are a little calmer, you know, the Evans, the Omars, those kind of guys who are very calm, who try and figure things out. If you're closer to me, this is more what it looks like. If you know, I don't want to see these things. The new kit, on the other hand, is it's cloud-based, it's graphic, it's intuitive. Case in point, I set up the Gov Wi-Fi access with minimal assistance. Well, until Rob came and started talking about wanting to add more stuff to it. Then I had to run to Ido to get some help. But the point is, this is much easier to learn. And in turn, it's much easier to teach this to someone else who may not have the time to go through it than telling them about commands that if you type that command and type that command, you'll get this. So that's it for the access layer. And we now go to the distribution layer. The distribution layer and the core layer tend to be, we treated them in one fell swoop. And why is that? Well, the hardware at those layers tend to be very closely related. In some instances, you can find a company running the same devices at their core layer as they do at the distribution layer. I mean, even in our case, I just pointed out that what we have as our core layer, well, we've got 2 of them in the distribution layer. As a matter of fact, those 2 devices are actually based in the HSC. So, you know, if you slip me a pony, I might be able to show them to you. But the point here is we handled them, these 2 layers, as one because of that. The other thing that we did here was we decided to integrate more closely with the architects because they were designing the data center at that time. And we thought it's a good idea to ensure that whatever we're doing on the user network marries up with whatever they're doing in the data center. So it was a 3-way rumble for that one. And the contenders there were Aruba, HP's little brother, still smarting from having narrowly lost the first round. But Meraki doesn't join them this time. Instead, well, let me explain a little bit. We found that even in testing for the access layer, we found that Meraki's characteristics, while solid for the access layer, didn't make for good reading when it came to the distribution layer. And so we decided, probably look elsewhere. So they tagged in their big brothers. But I will say one thing going for Meraki was that the grilled chicken in their canteen is to die for. The third party is Open Compute. It's actually a combination of companies from the Open Compute project. And these guys might well represent the future of networking. You've got a switch that's designed around open standards, running an operating system that's designed around open standards. So there are 2 companies here presenting the solution. Mellanox presented us with the hardware, and Cumulus presented us with the operating system, a form of Linux that was specifically tweaked to run as a network operating system. They fell short on 2 points. The first point was that it seemed that their solution was more geared towards the data center. But the even more egregious failure, at least in my book, and it's my book that matters, is that their kit only speaks this language. Again, if you're on the infrastructure team and you're not Isaiah and you're not Ido, well, this is more likely going to be you. And this is you if you're still trying to make sense of things. I've told you what it would look like if it was me, okay? So 3 became 2, and it became Aruba versus Cisco. It was a much more straightforward affair this time. We simply went in and tested for a very narrow, definitive set of characteristics that you will need at the access layer. And what we were looking at was, 1, is it cloud managed? Is it cloud manageable? How easy is it to use? Now, on these first 2 grounds, Cisco was winning by a smidge. Cisco's interfaces were cleaner, they were easier to use, it was more intuitive. Aruba wasn't far behind, it was just that Cisco was better. The licensing was where we now started separating them. The Cisco licensing was so complicated that you're looking at paying for things that features that you may not have turned on because they were not, that's how their licensing works. Now, does this sound familiar to anything I said at the beginning? How much does it cost? It cost 130 grand more to go with the Cisco solution, as clean and polished as it was, than to go with the solution from Aruba. And of course, we conducted a host of other tests, more technical tests, to determine which of these 2 is it that's going to be. Are we going to go for ease of use and cloud manageability, brand name, good pedigree? Or are we going to go for, look, you do what we want to do, we want to get to the internet, that's all we want, and so on and so forth. You've given us an easy license, and you're not prohibitively expensive as far as we're concerned. Now, if I were with you guys, I would have asked, who do you think is going to win? But since we're apart, I would simply say the solution from Aruba won. And if you've been listening closely, you might be able to predict who won the battle of the core. Also, the solution from Aruba. Now, these solutions, they speak the old language, but you will mainly come across this when you're trying to set up the device. That's when and it's easier for our 2 networking Jedi Knights to write documentation. If you need to say type this command and type that command and type that command, it's easier for them to write documentation for how to set up a device than for them to document how to troubleshoot problems that they don't know will ever occur, or to fail to document problems that eventually do occur. So when they speak the new language, of course, it looks more like this. And this is what you will come across when you're trying to manage the device on a day-to-day basis. Obviously, if you have a bit of a problem that requires you to go back to the command prompt, you might, in isolated incidents, you might be able to pick up 1 or 2 things to get you along. But for the most part, this is what it looks like for management. So that's it for the kit. How does it hang together? Well, all the dark fiber connections will remain. But for everybody else, all those guys that have to connect back to us using LAN extensions and so on and so forth, all those guys that have to use VPN, they will connect independently to the internet, directly to the internet on their own. And that makes sense, right? Because there is no data that is being held only on HackIT's premises. You want to go to VDI, you can do that from the internet. We're doing that from home right now. So any place that is not on the dark fiber goes directly to the internet. So who's providing us with this internet connection? We put out an open tender, and we hoped more people would respond But of the big boys, only Virgin responded, and they were, you know, they weren't very flexible to things like our timelines and things like that. They weren't. So in the end, we went with a few charming tyros. All three of them want to give us 1 gigabit internet connection wherever we give them the contract. But the three partners in this are Community Fiber, relatively new. They came to see us. Very good presentation. Optimity, these guys are unique for 2 reasons. One is that they're Hackney based, buy local, I suppose. The other is that their internet connection is not delivered via laying fiber optic cables or things like. They simply put an antenna on top of a building and send you internet that way. So pretty novel, pretty neat. We actually asked them if, you know, if it was proof, if it was weatherproof, and they were very happy to tell us that it was. The third person in this fight is Hyperoptic. Most likely this will be the most famous of them all. You'd have heard of them in the new build projects and things like that. So these guys, we've got 10 proof of concept sites that we've split out amongst these 3. And we said to them, go on and set up internet in these places. Let's see what you've got. And so they've had to go and get legal documentation, something called a way leave, which is kind of like permission to dig up the sidewalk so that you can lay your cables and things like that. So they're getting, some of them have got that documentation, and they've begun the process of installing the internet in these 10 proof of concept sites. So what we're going to do is that we're now going to observe them after they finished their installation, see how they do, how their customer services operate, and we'll make a choice as to who provides internet to the remaining 40-something sites. So the next steps for us now are between Rob and Henry, one of them to sort out the procurement thing, you know, get the business case signed so we can go to market, get the kit, cable up the sites, put the Wi-Fi in, start testing, and eventually make a decision. So all that is in the future, but for now, I'll take questions.
And hi everyone, it's Jay here. You're welcome to type in your questions as well in the chat.
Okay, we've got 20 questions already in the chats. Matthew Keyworth says +1 for the GOT reference. Okay, grilled chicken in the canteen is to die for. Does anybody have a question?
So Chidi, Peter's asked whether some of the small suppliers are going to survive the lockdown shutdown. I don't know whether you're in a position to answer that one.
If I had the Minister for Business, he might be able to answer that better than I can. I think he took ill with coronavirus yesterday, so
I can probably answer it. So the connectivity is still a priority service during the pandemic, and all these companies are still working. So they are, not only are they going to survive the lockdown, I suspect they will probably do quite well commercially out of it, because everybody now wants connectivity even more than they wanted connectivity 3 months ago.
That's a good answer.
Thank you.
We have another question. Are any PLC sites live?
Not yet. Not yet. They were on the verge of going live before the COVID hit. And you'll remember that at the beginning of the COVID, most companies were concerned with protecting their people, and that's understandable. So, but at the moment, some people have started getting back to us saying, I'm doing a piece of work with Paul Honzi at the moment, where one of the cabling agents has come back to us to say, do you know what? Now that there are fewer people in the offices, now may be a good time to do the cabling without disrupting business. So the short answer to that question is no, none of the POC sites are live yet, but we are not very far away from making them live.
So I think that's probably your time. But Chidi, can I thank you for what was a really interesting show and tell? And you covered an enormous amount of ground, and you managed to bring it in 30 seconds before the full half hour. So well done.
Thank you. All right. So without much ado, see you guys.
Take care, Chidi.
Bye, everyone.
Take care.
Yes, Chidi.
Well done, Chidi.